We know what is data, we know what is information, we know what is database, and we know what is database system. Database system is a computerized record keeping system, and remember, this is a primitive one. There may not be a major sophisticated software functionality that might be built into it, a simple database system. At the end of this video, you will be able to define what is a database management system, its functions as well as benefits. When it comes to DBMS, I say it is a set of software programs that control the organization, storage and management as well as retrieval of data in the database. So, when I say a database, we know that the disadvantage of simply storing the data in a simple file system, just in terms of files and trying to read using some simple programs. But however, here what I am trying to introduce one more layer called DBMS in between the file system and the storage, the data storage layer. We know that there is a lot of disadvantage if I directly store the files in maybe we know that that say for example, if I say savings account, if I store it in savings account dot file, some recurring deposit, I will say recurring deposit some related files, and if I just try to simply manage, we know the difficulties or issues involved in that. But look at in this, I am introducing one more layer of DBMS here, which sits in between the applications which read the data and the data which is stored in the file system, so DBMS. So, what does this DBMS do? Database management system. It helps me in obviously properly managing the data management, defining the data. That defining the data means data definition. That means if I am storing customer related data, what is that format that I want to store it in? If it is student related data, what is that format? I need to define it appropriately, define a proper boundary to this. Appropriate transaction support. We know a transaction is nothing but a logical set of activities which all or none, the concept of all or none. So, when I say a transaction is complete, all these activities should be complete. It is not that some activity is complete, some activity, no, it is not that. So, either 0 or 1 kind of a thing. If I want to update the data, you know that the read the data, lock it in all the sites so that nobody will be able to update when I am doing the update, and when I am done with the update, make the changes permanent and release all the locks, so that somebody else will be able to do the changes. That is what is transaction support. Concurrency control. We also know that it is not that only one user who will be accessing the data, there can be many, especially in case of a networking environment. Many people may try to access the data. Just take for example, we know that if in case of a ticket reservation system, we know that railway reservation system, the site is very busy, especially in the morning 8 o'clock. We know that many times we get page cannot be found or something. Why? Because thousands of people are trying to access the same data maybe. So, concurrency is allowing multiple people to access the data at the same time. Should we allow it or not? Yes, I have to allow that, because so that the throughput of the system is increased. On the other hand, if I do not take care of proper concurrency, controlling the concurrency, there is a possibility of I am messing the data and probably leading to the loss of data. So, a DBMS take care of appropriate concurrency mechanism. Just for example, if I have one service point is there and many people, for example, if you want to buy a movie ticket, only one person is there in the ticket counter. What happens if hundreds of people flock near the counter itself? He will not be able to manage. What we do? We come in a queue so that only one person at a time can be served. So, this kind of a mechanism is there in case of a concurrency control, which the DBMS provides. We also know that in a simple file system on a simple database, if there is a crash in the previous instance of the data, there is probably may not be a mechanism to recover the data unless I keep a latest backup always. But in case of DBMS, it provides a proper, even if the database there is a crash, there is a features or function, it provides functions to recover the data. That is what is the recovery mechanism. Appropriate, it is important that I need to keep my data secure, as well as integrity of the data also should be maintained. One data, if I store it here, the same data, the same information should reflect everywhere. For example, for an ID, student ID 1234, if the name is say XYZ, wherever application, if I say 1234, the same name should come. This is one of the small examples of integrity of data. There are various integrities, types of integrities. Okay. So, it has to ensure, DBMS will ensure appropriate security and integrity of data, and DBMS also provides different utilities. One of the examples of, for example, I have a database, set of data or database in my one system. If I want to export it to somewhere, some other machine, DBMS provides various utilities to export as well as import in different formats. So, these are some of the functions of a typical DBMS. When I say a set of software is a DBMS, they should provide, that DBMS should provide all these functions. And when it comes to the benefits, obviously sharing of data across applications. It is not that only one user should read or something, it says sharing of data across applications. Data redundancy gets reduced to a drastic level. Reduced data redundancy, enhanced security mechanism, so that data is kept secure. Data independence. In case of a database, if I just slightly change the format of the data, I may not change the corresponding programs which read the data. So, that kind of an independence may be there, provided by the DBMS. So, hence it certainly provides better flexibility for the application when they are accessing the data or storing or retrieving the data. One of the points in when it comes to the database, we call what is called as integrity constraints. A simple example, if I have to enter some customer's information, when I am putting a customer name, customer address and all those things, and if I am in a hurry, I may miss out something, or I may enter some wrong values. PIN code, we know that it should be 575004, whatever it is, 560001, it should be 6 digits. What happens if somebody enters 5 digits? Or phone number, if it is a typical mobile phone number, it should be 10 digits. What happens if I enter 15 digits or 6 digits? So, in case of a database, I can enforce this constraint. When you are giving the PIN number, it should be 6 digits only, or whenever you are giving the password should be this only. Whenever you are giving a phone number, it should be in this format. This is what I said, I can enforce this kind of an integrity constraint with the help of a DBMS. It also gives me a better transaction support. When we are talking about multiple users accessing the data or modifying the data, so it is very important that appropriate transaction management is taken care, which is certainly provided by the DBMS. And when it comes to different standards, businesses, like an example of a bank has certain standard that needs to follow, that is enforced by RBI, or maybe insurance, and different business standards are there. Database, with the help of a database management system, it's easy for me to enforce the standard that when I am storing the data. The last one in this is backup and recovery mechanisms. I can tell to the DBMS that do an automatic backup, or in case of a recovery, automatic recovery. These things can be done with the help of a DBMS. So, to conclude this video, let us try to summarize the points that we discussed here. A database management system is a set of software programs that control the organization, storage, management and retrieval of data in a database.